Hello class, in just under 6 or 7 minutes I'd like to address a few questions. I believe I have already went over these two examples, right? With all the groups, try to remember, yes? And then after these two examples of frequency tables and histograms and bar charts, I'd like to address four questions. Questions about frequency tables, bar charts, and histograms. 1, 2, 3, and 4. So let's think about this. The question number one is this: what is more suitable for the presentation of discrete data, a bar chart or a histogram? The book tells you the following: a histogram looks similar to a bar chart, but a bar chart is suitable for discrete data. I agree with that. I agree with that as long as the entries for the discrete data or the amount of data that you have, the data points, is rather small. Then a bar chart is perfectly okay. So let's go here. So yeah, when the amount of data is rather small, a bar chart is suitable, no problem. But then let's address the second question: can we use a histogram for discrete data? A histogram. The answer is yes. Yes, we can. There is no problem. I don't want you to think that when you deal with discrete data, you should always use a bar chart. No, you can also use a histogram. Why? Because using a histogram is more advisable when presented with a large collection of discrete data entries or data points. What do I mean by this? Well, let's look here. In this column, guys, I have data points. This is one data point, another data point, also known as data entries or pieces of data, whatever you want to call them. There are several ways you can address this each of these pieces of information: 6, 4, 41, 77, etc. And I have way too many. You see? Way too many. In fact, I have 1,000 data points, 1,000 data entries, and they are, if you notice, they are discrete, right? They are discrete, as you can see. Now look at the bar chart. If I wanted to do a bar chart for this data, look at it, okay? And conversely, look at the histogram. If I section all of these data points into 10 intervals, like all the entries in the range from 1 to 11, all the entries in the range from 11 to 21, and so on until 100, because that is the maximum range that I have. Look, this is much more telling, guys. This is much more telling than constructing a bar chart for this particular data set, because there are way too many data points. So, can you do a bar chart? Absolutely, no problem. There is nothing wrong with this. Now, if I expand this, can you see? So, in here, you are actually plotting for each single number. For the number one, how many frequencies do we have? About, I cannot see. Well, about 5 or something. And then for the same for each number. But this is not too telling, in my opinion, right? Instead, if we plot a histogram, this conveys more information about this specific data set. So either way, both work fine. But in my opinion, and in the opinion of many mathematicians, constructing a histogram is better, even when you deal with discrete data, when you have too many data points. Too many data points, then histogram is okay. So that solves these two questions. Question number 3. What is more suitable for the presentation of continuous data, bar chart or histogram? In this case, we will always use a histogram for continuous data. Okay, because even though technically speaking you can use a bar chart, that's not gonna offer any information, any real meaningful information about a continuous data set. And in this regard, the book is rather definite. You can read it here. When you are working with continuous data, you should use a histogram. And I agree right there. I agree 100%. Okay. And the final question. This is a very important question. Are there any rules for getting the number of class intervals, also known as bins, as I've told you, that a histogram should have? Because as you may remember, a histogram has these little sets, like these widths, these classes. They're known as class intervals or bins. In this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 class intervals, 10 bins. But how do we decide on the number of class intervals? How do we do that? Consider that if there are too few class intervals or too many, we may not be able to observe a clear pattern in the data. And let me show you what I mean. Let's experiment with this data set. In here I have this data set with 12 data points, 12 data entries. And let me bring this, I'm gonna go control copy, and I'm gonna bring that information to this histogram maker. I'm gonna put it here. Okay, and let's generate the histogram. So this software automatically gave me 4 class intervals. Why 4? Why 4? Like, on what criteria is this program deciding on 4 class intervals? Why not 8? Why not 2? Well, there are some reasons for that. But let's first observe how, if I go for something like this, just two classes, let's see what's happened. Okay, look at this. This is not too telling. As for example, if I decide for 3 class intervals, look at the pattern that we can observe in the histogram. If I decide for 4, look at the pattern. And you see, this is much more telling. If I decide for 5 class intervals, let's edit. And that's not too good. And if I go for even more, 6 class intervals, nah, we can kind of see like this is not good, right? Let's exaggerate the point. Let's go for 10. 10 class intervals. You see? So depending on the class intervals, the number of class intervals that you go for, you can observe different patterns in the data. And there are some rules. There are some rules for deciding about the number of bins and width. Just pay attention to this. There is no best number of bins, and different bin sizes can reveal different features of the data. There is no best number of bins. Pay attention to that. Some theoreticians have attempted to determine an optimal number of bins, but these methods generally make strong assumptions about the shape of the distribution. Depending on the actual data distribution and the goals of the analysis, different bin widths may be appropriate. So experimentation is usually needed to determine an appropriate width. You see? And this is kind of like what I've been telling you. You need some experience or some experimentation in statistics in order to decide what's a good number of bins or what is a good sampling technique, etc., etc. It's quite tricky. And here we have at our disposal. I mean, they're offering you some rules, some formulas in order to determine the number of class intervals. And we're not gonna take a look at them, by the way. We will not. I just want you to understand that the number of classes can follow some criteria also. And we probably can talk about this one only on Monday. But let me think about it. So that's it, guys. That's it. That's all I wanted to talk about. Thank you so much. See you on Monday. Have a good day.